Ladies and gentlemen, boys and girls, children of all ages. Didn't I move you, Jason? Yeah. No, now I did.
He said he was going to.
Now I did. Back there. Now, we have previously done multiplying a whole number times a decimal. We have previously done that. And I just want to show you real quick, because you're going to see two of those questions today on our warm-up, what that looks like. We have 3 groups of 2/10. And that gives us a total of 6/10. I mean, whole numbers times decimals using the model. Shut your computer. Whole numbers times decimals using the model. Very easy. What we're going to do today is also very easy. Today we're going to multiply tenths times tenths using the model. You saw one of these, so let's take 7/10 times 4/10. You saw one of these on last week's spiral review. Whenever you're doing a model like this, it's always, and I mean always, going to be tenths times tenths. Most of the questions you see like this are going to be saying, hey, which equation goes with this model? Just like the one on this spiral review last week. And every number that you're going to get here is going to be on every answer choice. A 7 will be on there and a 4 will be on there. Maybe it'll say 7/100 and 4/100. Maybe it'll say 7 times 4. You have to know how it's being done. The way it's being done is you have 7/10. You take 7/10, and we're going to do 7/10. And this is 7/10. And ideally it would be shaded in, but I want you to be able to see it. And then you take 3/10, and you go 4/10, and you go the other direction. And so when it's shaded, and they'll be shaded in the pictures and stuff when you do it, but the part that is shaded by both of them is your answer. Your answer's always going to be in hundredths. It's always going to be in hundredths. It's always going to be in hundredths. And all you have to do is count how many hundredths are in there. Joel?
28.
28 hundredths. Now Joel knows that because the standard algorithm for multiplication, if I were doing multiplication and using the standard algorithm, I would have 7/10 times 4/10. Now multiplying by decimals, you don't just move the decimal point down. First thing you do is you ignore the decimal point and just multiply the numbers that are there. Obviously, I don't have to put 0 in front of it because... Oh, well, I did an 8 again. Obviously, you don't have to put the zeros in front of it because that'd be cray-cray. And then you multiply 28. 7 times 4 is 28. Then I go back. This is jumping ahead here. Then I go back and I find out how many numbers are behind the decimal point in the problem. And that's how many are behind it in the answer. So really, once I get into doing the multiplying decimals using the standard algorithm, it is easy peasy raw chicken squeezy. And again, another one. We have, let's go 4/10 times 9/10. And obviously that's going to equal what? 36 hundredths. We just have to remember our answers are always going to be in the hundredths. And when we're doing decimal by decimal, our factors are always going to be in the tenths. So that would be, no, our factors are always in the tenths. Our product is always in the hundredths. And you just, if you had to draw it yourself or work it out yourself, you would just go one horizontal, and it doesn't matter, and one vertical, and then count their numbers that are in there. Allie. Well, yes, you'd multiply 9 times 4, and you'd get 36, but you can't, there's a reason why you put it in front. Because there are 2 numbers behind the decimal in the problem. That means there'd have to be 2 numbers behind it in the answer.
So you wouldn't put it in between the 2 numbers?
I wouldn't put it in between. I always go back to my problem and I just count. 1 decimal here, or 1 number here, 1 number here. Both behind the decimal point. That means there needs to be 2 behind the decimal point in the answer. Yes, ma'am.
Wouldn't it be 3.6?
No. 3.6 would be 1, 2, 3, and then 6 rows of this. Okay? Because 9 times 4 is 36, right? Then I go back and I look at the problem. There's 1 digit behind the decimal point here and 1 here. If I add that together, that's 2 numbers behind the decimal point. There needs to be 2 numbers behind the decimal point in my answer. Because I'm multiplying by less than 1 times less than 1. If I'm multiplying by numbers less than 1, it's going to be smaller than my factors, than my biggest factor. Probably than all my factors. I don't remember. Smaller than my biggest factor. So when I'm multiplying by here, my product always is going to be smaller. It's going to get smaller because I'm multiplying by less than 1. 1, it's going to stay the same. Greater than 1, it's going to get bigger. Less than 1, it's going to get smaller. And let's look at uno mas. Uno mas. That means one more.
I know.
One more.
I'm Spanish. Uno more. 1 more.
All right, let's do 7/10 times 2/10. We obviously know the answer is
1400.
1400. Okay, but 7/10, this is what it would look like. Except it would be shaded in. And 2/10. And it would be shaded by both the red and the black, which would make it hard to do in here without messing up my markers. Yes, ma'am.
So there's after where the black is and the red, there's more red. You don't count that.
No.
We just count the part that's
Just-
shaded in both.
Just the part that is in both. Just the part that is in both. And on the question you had on the skills review, it had them that way, and it was just a darker gray. It's kind of how it was written. Okay, so it's easy peasy raw chicken squeezy. No problem doing it. And I actually jumped ahead because I'm not actually getting to the standard algorithm for multiplication until next week. Yeah, you guys are going to be brillianter than the rest. Boom. Shakalaka, peace out. God bless. Love you. Do something kind today. Save the beast, please. Subscribe. I want to be rich and famous.